Welcome! In this video, we are going to take a look at problem 1 from chapter 23 of College Physics 2E by OpenStax. Alright, in problem 1, we need to consider the two coils that are in part A of the figure, and we need to find the value of the magnetic flux at coil 2 due to coil 1. Okay? And we are also told that the planes of the two coils are perpendicular. Okay. So coil 1 makes a field that comes out of the page and it curls around over to coil 2. It makes circles that go through the center of coil 1. But the coils are perpendicular. And so we can show that coil 2 will not have any flux going through it. Okay, so flux is B dot A, and the magnitude of flux then is B times A times the cosine of theta. Theta is the angle between the magnetic field and the normal to the area. Okay, and so the field comes out of the page, goes over to coil 2, and at that point it's into the page. So let's just draw an end looking at coil 2 right on edge. And so we'll have fields going like this, but the normal to the area is going like this. We can use an n hat. And so the angle between those two is 90 degrees. And so we can say, so theta is 90 degrees. And we know that the cosine of 90 is 0. So we can say, well, the flux is B times A times the cosine of 90. Doesn't matter what B and A are because, as we said, cosine 90 is 0. So the flux through coil 2 is 0. Okay, and we can tack on units, either Webers or Tesla meters squared. Okay, I hope you found that helpful. Let me know in the comment section if you have any questions. Thank you for watching, and I'll see you in the next one.